TOEFL Speaking Task 4, 25 practice tests plus model answers, and this is Michael from BetterTOEFLScores.com. What is TOEFL Speaking Task 4? Task 4 is an academic listening and speaking task. You listen to a short lecture on an academic subject. Then you will summarize the main idea and supporting details in your own words. And this is what makes it hard. You have to use your own vocabulary and your own grammar to re-explain a conceptually difficult idea. You have 20 seconds to prepare, 60 seconds to speak. To get a high score, keep in mind, take very clear notes during the lecture. Make sure you understand the main idea. You have 2 to 3 key details. Use transition words, things like first of all, next, or for example, to help show the organization of your ideas. Make sure you paraphrase. Do not repeat the lecture word for word. Stay organized. State the main idea and then explain the supporting points. That's logical. Practice pacing. You need to be speaking about 120 to 150 words per minute. So what kinds of skills do you need to do well with this kind of speaking practice test? You have to have good listening comprehension. You need to be able to understand conceptually dense academic lectures. You have to have good note-taking skills. You need to be able to identify and then jot down in note form the main points and examples. You need paraphrasing and summarizing skills. Remember, paraphrasing is to take a sentence that's roughly 20 words and to rewrite it in your own grammar and your own vocabulary in about 20 words. Now, summarizing is to condense a large portion of text to a much smaller portion. You need to have both of those skills. You need to have fluent speaking delivery. You have to have good tone. You must vary your tone throughout your response. You have to have good pacing. Make sure that you're not pausing unnecessarily. You're not including a lot of unnecessary hesitations. You have good clarity. It's easy to understand what you're saying. Practice test 1, the concept of altruism in biology. Today I want to talk about a fascinating concept in biology known as altruism. In everyday language, altruism refers to selfless concern for the well-being of others. In biology, it describes behaviors by which an individual decreases its own chances of survival or reproduction, but increases those of another individual. At first glance, this seems to go against the principle of natural selection, which emphasizes survival of the fittest. However, when we look closely, altruistic behavior often contributes indirectly to an organism's genetic success. Let me give you the first example. Meerkats in the desert. These small mammals live in groups, and while most members forage for food, 1 or 2 individuals act as sentinels. The sentinels stand on their hind legs, scanning the sky and landscape for predators such as hawks or jackals. If they spot danger, they emit a loud alarm call. This warning gives the foragers time to hide in burrows, increasing their survival chances. But here's the catch. The sentinel is more exposed and less likely to escape in time. From an individual perspective, the sentinel's action is risky. From a group perspective, however, it helps relatives survive, and since relatives share genes, this indirectly promotes genetic success. Now consider vampire bats. These bats feed exclusively on blood, which is not always easy to find. If a bat fails to feed for 2 consecutive nights, it may starve. To prevent this, well-fed bats sometimes regurgitate blood and share it with hungry companions. What's interesting is that bats usually share with individuals that have helped them in the past or with close kin. So while it looks selfless, this sharing increases the likelihood of mutual support in the future and helps relatives survive. In both cases, altruism reduces the immediate benefit to the individual, but increases the long-term success of the group or kin. This helps us understand Why altruistic behaviors persist in nature. The professor in the lecture explains the biological concept of altruism. Using examples from the lecture, summarize the concept and how the professor illustrates it. Model answer. In the lecture, the professor discusses a biological concept of altruism, which is when an individual sacrifices its own survival chances to benefit others. The main idea is that even though altruism appears selfless, it helps genes survive in the long term. For example, the professor describes mercots. While most are busy looking for food, one animal stands guard. If danger appears, it calls out to warn people, even though the sentinel risks being caught. This behavior protects relatives and ensures that shared genes continue. The professor also mentions vampire bats. When one bat fails to find food, another will share blood by regurgitating it. This helps close relatives and also builds a system of mutual support. Therefore, altruism is not really against evolution. Instead, it ensures that either relatives or future cooperation increases survival for the group. Practice test 2, photosynthesis and adaptation in plants. Today, I'd like to discuss the process of photosynthesis and how plants adapt this process in different environments. Photosynthesis is the method by which plants convert sunlight, water, and carbon dioxide into glucose, their source of energy, while releasing oxygen as a byproduct. It is one of the most important biological processes on Earth because it sustains both plant life and the animals that depend on oxygen and food. However, not all plants live in the same conditions. Plants in different environments have adapted photosynthesis to survive under challenging circumstances. Let me explain with 2 examples. First, consider cacti in deserts. Desert conditions are extremely hot and dry. If plants open their stomata, the tiny pores on their leaves during the day, they risk losing too much water. So many desert plants use a method called CAM photosynthesis. In this process, they open their stomata only at night to take in carbon dioxide. They store this gas and use it during the day when sunlight is available. This adaptation allows them to minimize water loss while still making food. Second, think about corn plants in warm climates. Corn uses a process called C4 photosynthesis. This system is more efficient at capturing carbon dioxide in hot and sunny environments, preventing energy waste. By doing so, corn plants can continue to grow quickly even when conditions are stressful. Both of these adaptations demonstrate how photosynthesis, though universal, is adjusted in plants depending on where they live. Cacti conserve water, and corn maximizes energy use. These strategies show that photosynthesis is flexible and critical to survival in diverse ecosystems. The professor discusses photosynthesis and how plants adapt it in different environments. Using the examples from the lecture, summarize the process and explain how the professor illustrates it. Model response. In the lecture, the professor explains photosynthesis and how plants adapt it to survive in different environments. The main idea is that although photosynthesis is universal, plants have developed special methods to deal with stress. For example, cacti in deserts use CAM photosynthesis. They open their stomata at night to take in carbon dioxide and store it until daytime, reducing water loss. This allows them to survive in very dry climates. The professor also describes corn plants, which use C4 photosynthesis. This method is efficient at capturing carbon dioxide in hot conditions, so corn can grow quickly even in challenging climates. These examples show that photosynthesis is flexible. By adapting the process, plants can live in extreme environments and can continue to make food. Overall, photosynthesis is essential not only for energy, but also for survival under diverse environmental pressures. Practice test 3, the greenhouse effect. Today we're going to talk about the greenhouse effect, a natural process that warms the Earth's surface. The greenhouse effect occurs when certain gases in the atmosphere trap heat from the sun. These gases, often called greenhouse gases, include carbon dioxide, methane, and water vapor. Without them, Earth would be too cold to sustain life. However, human activity has intensified this natural effect, leading to concerns about global warming. Let me explain with two examples. First, consider volcanic eruptions. When a large volcano erupts, it can release enormous amounts of carbon dioxide into the atmosphere. This additional greenhouse gas traps more heat, raising global temperatures. Although volcanic activity is natural, it demonstrates how an increase in greenhouse gases can alter Earth's climate. Second, look at human activities like burning fossil fuels. When people drive cars, use electricity, or operate factories, they burn coal, oil, or natural gas. These actions release large amounts of carbon dioxide and methane into the air. The result is a stronger greenhouse effect. Scientists have measured that the Earth's average temperature has risen over the past century, and human emissions are the primary cause. So while the greenhouse effect is necessary for life, too much of it can be harmful. Natural events like volcanoes can contribute, but human activities are now the dominant factor in increasing Earth's temperature. The professor describes a greenhouse effect. Using the examples from the lecture, explain the concept and how the professor illustrates it. Model response. In the lecture, the professor explains a greenhouse effect, which is the process by which gases trap heat and warm the Earth. The main idea is that although the effect is necessary for life, it can become harmful if it becomes too strong. The professor first describes volcanic eruptions. Volcanoes release large amounts of carbon dioxide, which increases the greenhouse effect and raises temperatures. Then the professor gives a second example. Human activities like burning fossil fuels. Cars, factories, and power plants release carbon dioxide and methane into the air, which has caused a noticeable rise in global temperatures. These examples show that while the greenhouse effect keeps Earth warm, too much of it leads to global warming. Overall, the lecture demonstrates that human influence has made the natural greenhouse effect dangerously stronger. Practice test 4, the theory of multiple intelligences. Today I want to discuss Howard Gardner's theory of multiple intelligences. Traditionally, intelligence was measured by IQ tests, which mainly focus on math and language skills. Gardner argued that intelligence is much broader, and he proposed several distinct types. His theory changed the way educators think about student learning. Let me give you two examples. First, musical intelligence. Some people excel in recognizing rhythms, tones, and patterns of sound. For instance, a talented musician might not do very well in math, but can compose a song, remember melodies, and play instruments with ease. This demonstrates a form of intelligence that IQ tests usually overlook. Second, bodily kinesthetic intelligence. This refers to the ability to use one's body effectively. Athletes and dancers are good examples. A soccer player, for example, needs to control movement, coordinate with teammates, and respond quickly to changing situations on the field. These skills require intelligence, but not necessarily the kind measured on paper tests. Gardner's theory suggests that intelligence is not limited to one or two skills. Instead, people can be intelligent in different ways, through music, physical ability, social skills, or other talents. This theory helps educators design teaching methods that respect different strengths. The professor describes Gardner's theory of multiple intelligences. Using the examples from the lecture, explain the theory and how the professor illustrates it. Model answer. In the lecture, the professor explains Gardner's theory of multiple intelligences. The main idea is that intelligence is not limited to math or language, but exists in many forms. The professor first describes musical intelligence. This is when people understand rhythms and tones well. For example, musicians can compose songs and recognize melodies even if they're not strong in traditional subjects like math. The second example is bodily kinesthetic intelligence. Athletes and dancers demonstrate this type by using their bodies skillfully. A soccer player, for instance, shows intelligence by coordinating movements and reacting quickly on the field. These examples show that intelligence can take different forms and cannot be measured with only one standard IQ test. Overall, Gardner's theory broadens our understanding of human ability and helps teachers value different student strengths. Practice test 5, keystone species and ecosystems. Today, I want to talk about keystone species and ecosystems. A keystone species is an organism that has a disproportionately large impact on its environment relative to its abundance. If a keystone species is removed, the entire ecosystem may change dramatically. Let me illustrate this with two examples. The first involves wolves in Yellowstone National Park. In the early 20th century, wolves were hunted to near extinction. Without them, deer populations increased rapidly. These deer overgrazed plants and weakened riverbanks, which caused soil erosion and reduced habitats for other animals. When wolves were reintroduced in the 1990s, they began hunting deer again. This reduced the deer population and allowed vegetation to regrow, which stabilized riverbanks and supported other species. The wolves, although few in number, restored balance to the ecosystem. The second example is sea otters along the Pacific coast. Sea otters feed on sea urchins, which, if left unchecked, can destroy kelp forests by eating the roots. When otters are present, they keep sea urchin numbers low, which allows kelp forests to thrive. These forests provide habitats for fish and other marine animals. So by controlling sea urchins, otters indirectly support entire marine ecosystems. In both cases, the presence or absence of a keystone species dramatically affects the health and structure of the ecosystem. The professor discusses keystone species. Using examples from the lecture, explain the concept and how the professor illustrates it. Model response. In the lecture, the professor explains the concept of keystone species, which are animals that have a huge impact on their ecosystems. The main idea is that even if these species are not numerous, they help maintain balance. The professor first gives the example of wolves in Yellowstone. When wolves were removed, deer multiplied and destroyed vegetation, but when wolves returned, plants regrew and riverbanks stabilized. The second example is sea otters. They eat sea urchins, which would otherwise destroy kelp forests. By controlling urchins, otters help keep forests survive, which provides habitats for many other animals. These examples show that keystone species are essential for maintaining ecosystems. Without them, entire habitats can collapse. Practice test 6, classical conditioning in psychology. Today, I want to talk about classical conditioning, an important concept in psychology. Classical conditioning is a type of learning where an organism associates a neutral stimulus with a meaningful one, eventually responding to the neutral stimulus as if it were the meaningful one. This type of learning helps explain many automatic behaviors. Let me illustrate this through two examples. The first and most famous is Pavlov's dog experiment. Ivan Pavlov, a Russian scientist, noticed that dogs salivated not only when they're given food, but also when they saw the lab assistant who normally fed them. To test this, Pavlov rang a bell each time he gave the dogs food. After many repetitions, the dogs began to salivate when they heard the bell, even if no food followed. In this case, the bell, originally a neutral sound, became associated with food. The second example involves human phobias. Suppose a child has a frightening encounter with a dog. Perhaps the dog growls and lunges at them. Later, the child might feel fear even when they see any dog, even a harmless dog. The neutral stimulus, which is simply the sight of a dog, becomes associated with fear. This shows how classical conditioning can influence human emotions and behaviors. In both examples, a neutral stimulus, like a bell or the sight of a dog, takes on new meaning because of repeated pairings with an event. Classical conditioning, therefore, helps us understand how organisms learn automatic reactions to their environment. The professor describes classical conditioning. Using the examples from the lecture, explain this concept and how the professor illustrates it. Model response. In the lecture, the professor explains classical conditioning, which is a form of learning through association. The main idea is that a neutral stimulus can cause a reaction once it's paired repeatedly with something meaningful. The professor first describes Pavlov's dogs. When a bell was rung before food was given, the dogs eventually salivated just at the sound of the bell, even without food. This shows how a neutral sound became connected with eating. The second example is human phobias. A child has a frightening experience with a dog, might later feel fear at the sight of any dog, even harmless ones. In this case, the dog becomes associated with fear. These examples show that classical conditioning explains how people and animals can learn automatic behaviors through repeated pairings or experiences. Practice Test 7. Plate tectonics and Earth's surface. Today, I want to explain the theory of plate tectonics, which is central to geology. This theory states that Earth's outer shell is divided into large plates that float on the semi-fluid mantle below. The movement of these plates shapes Earth's surface and causes many geological events. Let me give you two examples. The first involves mountain formation. When two continental plates collide, the pressure forces the crust upward, creating mountain ranges. For instance, the Himalayas were formed by the collision of the Indian and Eurasian plates. This process continues today, so the Himalayas are still rising. The second example is earthquakes. These occur when plates slide past one another along fault lines. Pressure builds as the plates stick, and when they suddenly shift, the ground shakes. The San Andreas Fault in California is a classic example of this process. Movements along the fault cause frequent earthquakes in that region. Both of these examples, mountains and earthquakes, demonstrate how plate movements constantly reshape Earth's surface. Plate tectonics provides a framework to understand not only the physical landscape, but also natural hazards. The professor describes a theory of plate tectonics. Using the examples from the lecture, explain the concept and how the professor illustrates it. Model response. In the lecture, the professor explains plate tectonics, which is the idea that Earth's surface is made of plates that move slowly over time. The main idea is that these plate movements shape the Earth's surface. The first example is mountains. When two continental plates collide, the crust pushes upward and forms mountain ranges. The Himalayas are a result of this process. The second example is earthquakes. These happen when plates slide past each other and then suddenly release built-up pressures, causing the ground to shake. The San Andreas Fault in California shows this process in action. These examples demonstrate that plate tectonics explains both the creation of landforms and natural disasters. Overall, the theory gives scientists a way to understand how Earth's surface changes. Practice Test 8, the Green Revolution. Today I want to discuss the Green Revolution, a period in the mid-20th century when agricultural practices transformed dramatically, increasing global food production. The Green Revolution involved new farming methods, improved crop varieties, and modern technology, all aimed at preventing hunger in developing nations. Let me give you two examples. The first is the development of high-yield wheat in Mexico. In the 1940s, scientists bred wheat varieties that produced more grain and resisted disease. These new strains allowed farmers to grow more food on the same amount of land, helping Mexico become self-sufficient in wheat production by the 1950s. The second example involves rice production in Asia. The International Rice Research Institute created new rice strains that matured faster and produced larger harvests. Countries like India and the Philippines adopted these varieties. With better irrigation and fertilizer use, rice production soared, helping to reduce famine in the region. The Green Revolution showed how scientific advances could solve urgent global problems. However, the professor also notes that while food production increased, the revolution also led to concerns about pesticide use and environmental impacts. Overall, the Green Revolution illustrates the power of agricultural innovation to address food shortages. The professor discusses the Green Revolution. Using the examples from the lecture, explain the concept and how the professor illustrates it. In the lecture, the professor explains the Green Revolution, which was a period of major improvements in farming that increased food production. The main idea is that new methods and crops help countries avoid famine. The professor first describes Mexico, where scientists created new wheat varieties that produced more grain and resisted disease. This allowed farmers to grow more wheat and help the country become self-sufficient. The second example is rice in Asia. Scientists developed new rice strains that grew faster and produced bigger harvests. With irrigation and fertilizers, countries like India greatly increased rice production. These examples show that the Green Revolution solved food shortages through science and technology. However, the professor also points out that it caused environmental problems like pesticide use. Overall, the Green Revolution demonstrates how agricultural innovation can both benefit and challenge societies. Practice Test 9, Renewable Energy Sources. Today I want to discuss renewable energy, which refers to energy sources that can naturally replenish and are environmentally friendly alternatives to fossil fuels. Renewable energy helps reduce greenhouse gas emissions and dependence on limited resources. Let me explain with two examples. The first is wind energy. Wind turbines convert the movement of air into electricity. When the wind blows, the blades turn and the generators inside produce energy. Wind power is clean, but it depends on consistent wind, so it is best in open plains or coastal regions. The second example is solar energy. Solar panels capture sunlight and turn it into electricity. This is especially useful in sunny areas with long daylight hours. Like wind, solar power is clean and renewable. However, solar panels require storage systems to supply energy at night. Both wind and solar energy illustrate how renewable resources can provide sustainable alternatives to fossil fuels. Although they have limitations, these energy sources play a growing role in addressing climate change. The professor describes renewable energy. Using the examples from the lecture, explain the concept and how the professor illustrates it. Model response. In the lecture, the professor explains renewable energy, which comes from sources that are naturally replenished. The main idea is that renewables provide alternatives of fossil fuels and help reduce pollution. The professor first describes wind energy. Wind turbines capture air movement and convert it into electricity. Although clean, it works best in regions with steady winds. The second example is solar energy. Solar panels convert sunlight into electricity, which is especially effective in sunny climates. Solar power, however, requires storage for nighttime use. These examples show that renewable energy is both clean and sustainable, even if it has challenges. Overall, the lecture establishes or emphasizes that renewables are vital for reducing greenhouse gases and protecting the environment. Practice 10. Cultural diffusion. Today, I want to explain cultural diffusion, which is a spread of cultural traits from one society to another. This process can involve food, language, technology, or traditions. Cultural diffusion happens through trade, migration, or communication, and it shapes the diversity of human cultures. Let me provide two examples. The first example is the spread of the tomato to Europe. Tomatoes originated in the Americas and were unknown in Europe until Spanish explorers brought them back in the 16th century. At first, Europeans were hesitant to eat them, but eventually tomatoes became central to Italian and Mediterranean cuisine, leading to dishes like pasta with tomato sauce and pizza. Are you getting hungry? The second example is the adoption of Buddhism in China. Buddhism began in India but spread to China through trade routes such as the Silk Road. Chinese monks translated Indian texts and adapted the religion to Chinese traditions. As a result, Buddhism became one of the most influential belief systems in East Asia. These cases show that cultural diffusion is a powerful force that shapes societies by mixing ideas and practices across regions. The professor explains cultural diffusion. Using the examples from the lecture, explain the concept and how the professor illustrates it. In the lecture, the professor explains cultural diffusion, which is the spread of cultural ideas and practices from one society to another. The main idea is that cultures change and grow when they adopt traits from others. The professor first describes how tomatoes spread from the Americas to Europe. They were originally unknown in Europe, but later became an important part of Italian cooking. The second example is Buddhism in China. The religion started in India but spread through the Silk Road. Chinese monks translated texts and adapted them to local traditions, making Buddhism very influential in East Asia. These examples show that cultural diffusion occurs through trade and communication and has lasting effects on societies. Overall, the lecture emphasizes that cultural exchange creates diversity and strengthens cultures. Practice test 11, the water cycle. Good morning, class. I want to explain the water cycle, the continuous movement of water on Earth. This process keeps water circulating through the atmosphere, land, and oceans, and it is essential for life. The cycle involves four main stages. First is evaporation, when the sun heats water in oceans, lakes, or rivers, turning it into vapor. The vapor rises into the air. Second is condensation. As vapor cools, it turns into tiny droplets, forming clouds. Third is precipitation, when clouds release water as rain, snow, or hail. Finally, we have collection, in which water gathers back into rivers, lakes, and oceans, starting the cycle again. Let's consider two examples. In tropical region, warm waters cause high rates of evaporation, leading to heavy rainfall and lush vegetation. Meanwhile, In mountainous areas, snow accumulates during winter. When it melts in spring, the water flows into rivers, providing fresh water for valleys below. These examples show how the water cycle varies depending on climate and geography, but always sustains ecosystems. The professor explains the water cycle. Using the examples from the lecture, explain the process and how the professor illustrates it. Model response. In the lecture, the professor describes the water cycle, which is the process by which water moves through the earth, or moves around the earth. The main idea is that water changes forms and locations but constantly recycles. The professor explains 4 stages: evaporation, condensation, precipitation, and collection. To illustrate, he first described tropical regions. There, high heat causes lots of evaporation, which leads to heavy rainfall that supports plants. He also gives the example of mountains, where snow builds up in winter. When it melts, it flows into rivers and supplies water to nearby valleys. These examples show how the water cycle works differently in various places, but always supports life. Overall, the lecture emphasizes that the water cycle is a continuous and vital natural process. Practice test 12, operant conditioning. Good evening. I want to discuss operant conditioning, a psychological theory developed by B.F. Skinner. Unlike classical conditioning, which involves automatic responses, operant conditioning focuses on how behaviors are strengthened or weakened by consequences. There are 2 main mechanisms: reinforcement, which increases behavior, and punishment, which decreases it. For example, consider classroom behavior. A teacher might use positive reinforcement by giving a student a gold star for completing homework. This reward encourages a student to continue the behavior. Negative reinforcement also works. For instance, if students do well, the teacher might cancel homework, removing something unpleasant. This motivates students to keep performing. Now let's take a look at animal training. Trainers often develop rewards for dogs with treats when they perform tricks. This positive reinforcement teaches the dog to repeat the behavior. On the other hand, if a dog misbehaves, the trainer might use a firm no, discouraging that action. Both examples show how consequences shape behavior, making operant conditioning essential for learning. The professor explains operant conditioning. Using the examples from the lecture, explain the concept and how the professor illustrates it. Model response. In the lecture, the professor describes operant conditioning, which is learning through rewards and punishments. The main idea is that consequences determine whether a behavior is repeated. The first example is a classroom. Teachers may give students gold stars for finishing homework, which encourages them to continue. They may also cancel homework if students perform well, which motivates them by removing something unpleasant. The second example is animal training. Trainers give dogs treats to reinforce tricks and use a firm no to discourage bad behavior. These cases show that positive and negative consequences shape actions. Overall, operant conditioning explains how both humans and animals learn through reinforcement and punishment. Practice test 13, urban heat islands. Today, I want to explain the concept of urban heat islands, which are areas in cities that are significantly warmer than surrounding rural areas. This effect happens because human activities and urban design trap heat. The first cause is building materials. Concrete, asphalt, and brick absorb heat during the day and release it slowly at night. Unlike forests or fields, these materials prevent cooling, making cities warmer. The second case is human activity. Cars, factories, and air conditioners release heat and pollutants, further raising temperatures. Let me provide two examples. In Tokyo, Japan, scientists measured temperatures in the city that were often several degrees higher than in nearby countryside areas. The dense concentration of buildings and vehicles trap heat. In Phoenix, Arizona, the combination of desert climate and rapid urban growth has produced extreme heat waves, worsened by the urban heat island effect. These examples show how urban planning and human activity intensify city temperatures. The professor explains urban heat islands. Using the examples from the lecture, explain the concept and how the professor illustrates it. Model response. In the lecture, the professor describes urban heat islands, which are cities that become hotter than surrounding rural areas. The main idea is that buildings and human activities trap heat. The professor first explains that materials like asphalt and concrete store heat and release it slowly, keeping cities warmer at night. He also notes that cars and factories add even more heat. For examples, the professor describes Tokyo, where city temperatures are several degrees higher than nearby areas. He also mentions Phoenix, Arizona, where the desert climate combined with urban growth creates extreme heat. These examples show that urban heat islands are caused by both construction materials and human activities. Overall, the lecture emphasizes that city design directly affects temperature. Practice test 14, symbiosis in nature. Today I want to discuss symbiosis, which is a close and long-term interaction between two different species. Symbiosis can be mutualistic, commercial, commensal, or parasitic. Sorry about that. Let me read that one more time. Symbiosis can be mutualistic, commensal, or parasitic, but the general idea is that at least one organism benefits. Let's take a look at two examples of mutualism. The first example is a relationship between the clownfish and sea anemones. Sea anemones have stinging tentacles that protect clownfish from predators. In return, clownfish clean the anemones and scare away fish that might harm them. Both species benefit from this partnership. The second example involves bees and flowering plants. Bees collect nectar from flowers as food. While doing so, they transfer pollen from one flower to another, which helps plants reproduce. The bees gain food, and the plants achieve pollination. These examples show how different species can cooperate for survival. Symbiosis is an important ecological concept that explains many interactions in nature. The professor explains symbiosis. Using the examples from the lecture, explain the concept and how the professor illustrates it. Model response. In the lecture, the professor explains symbiosis, which is when two species live closely together and at least one benefits. The main idea is that these interactions can help both species. The first example is the clownfish and sea anemones. The anemones protect the fish with their stinging tentacles, and in return, the clownfish clean and defend the anemones. Both species benefit. The second example is bees and flowers. Bees gather nectar for food, while they also spread pollen, which helps plants reproduce. These examples show that symbiosis creates partnerships that improve survival for both sides. Overall, the lecture emphasizes that cooperation is a natural part of ecosystems. Practice test 15, the Industrial Revolution. This afternoon, I want to discuss the Industrial Revolution, a period in the 18th and 19th centuries when society shifted from hand production to machine-based industry. This transformation changed economies, cities, and lifestyles. The first major factor was the steam engine. Before the Industrial Revolution, manufacturing relied on water and human labor. The invention of the steam engine allowed factories to be powered efficiently, which increased production. For example, in England, textile factories used steam engines to operate spinning machines. This greatly reduced the time needed to make cloth, lowering costs and increasing availability. The second major factor was transportation. Steam-powered trains and ships revolutionized the movement of goods and people. Factories could send products to distant markets quickly, and raw materials could be delivered more efficiently. For instance, coal and iron could be transported to industrial centers, fueling further growth. Together, these changes transformed society, shifting populations to cities and creating modern industrial economies. The professor described the Industrial Revolution. Using the examples from the lecture, explain the concept and how the professor illustrates it. In the lecture, the professor explained the Industrial Revolution, which was a major change from hand production to machine industry. The main idea is that new technology and transportation transformed economies. The first example is a steam engine. Factories used it to power textile machines, which sped up production and lowered costs. This made goods cheaper and more widely available. The second example is transportation. Steam trains and ships carried raw materials to factories and delivered products to markets. This helped industries expand. These examples show that the Industrial Revolution increased production and changed society. Overall, the lecture emphasizes that new inventions created the foundation of modern economies. Practice test 16. Photosynthesis versus cellular respiration. Today, I want to compare two essential biological processes, photosynthesis and cellular respiration. Although they are opposites, together they create balance in ecosystems. Photosynthesis occurs in plants. Using sunlight, plants take in carbon dioxide and water and convert them into glucose and oxygen. This process provides plants with food and releases oxygen into the atmosphere. Cellular respiration, on the other hand, occurs in animals and also in plants. During respiration, organisms take in oxygen and glucose, breaking them down to produce energy, while releasing carbon dioxide and water as waste. Let's look at two examples. First, consider a forest ecosystem. Plants absorb carbon dioxide and produce oxygen, which animals breathe in. The animals then exhale carbon dioxide, which plants reuse. Second, think about human activity. When people eat fruits and vegetables, they consume the glucose produced by plants. Their cells then use respiration to turn glucose into energy, powering daily activities. These examples show that photosynthesis and respiration are complementary. Together, they recycle gases and sustain life. The professor compares photosynthesis and cellular respiration. Using the examples from the lecture, explain the relationship and how the professor illustrates it. Model response. In the lecture, the professor compares photosynthesis and cellular respiration, showing how they work together. The main idea is that photosynthesis produces food and oxygen, while respiration uses those products to release energy. The professor first describes a forest. Plants create oxygen and glucose through photosynthesis. Animals breathe in the oxygen and release carbon dioxide, which plants reuse. The second example is human activity. People eat fruits, which contain glucose from photosynthesis. Their cells use respiration to release energy from the glucose, producing carbon dioxide as waste. These examples show that the two processes are opposites, but also complementary. Together, they recycle gases and maintain life on Earth. Practice test 17, the concept of opportunity cost. Today, let's discuss the concept of opportunity cost. Opportunity cost is the value of what you give up when you choose one option over another. It reminds us that every decision involves trade-offs. For example, imagine a student deciding between studying and attending a concert. If the student studies, they gain knowledge or perhaps a better grade, but the opportunity cost is missing out on the concert. If they go to the concert, they enjoy music and time with friends, but they might perform worse on their exam. The cost of each choice is the benefit of the alternative. A second example is a farmer choosing crops. Suppose a farmer can use land for either corn or soybeans. If they plant corn, they cannot use the same land for soybeans, so their profit from soybeans is the opportunity cost. These examples show that opportunity cost applies to both personal and economic decisions. The professor explains the concept of opportunity cost. Using the examples from the lecture, explain the idea and how the professor illustrates it. Model response. In the lecture, the professor explains opportunity cost, which is the value of what you give up when making a decision. The main idea is that every choice involves a trade-off. The professor first gives the example of a student choosing between studying and going to a concert. If the student studies, the opportunity cost is missing the concert. If they go to the concert, the cost is performing worse on the exam. The second example is a farmer choosing between planting corn and soybeans. If the farmer chooses corn, the opportunity cost is a profit they could have earned from soybeans. These examples show that opportunity cost affects both personal life and examples. Overall, the lecture emphasizes that people should consider opportunity costs when making decisions. Practice test 18, adaptation. Practice test 18, adaptation in polar animals. Today I want to discuss how animals survive in extremely cold environments through adaptation. Adaptations are physical or behavioral traits that improve survival in specific habitats. The first example is the polar bear. Polar bears have thick layers of fat called blubber beneath their skin. This insulation helps them stay warm in freezing Arctic temperatures. They also have white fur, which not only provides warmth, but also camouflage against snow and ice. This allows them to hunt seals more effectively. The second example is the Arctic fox. In winter, its fur changes color to white, blending with snow and helping it avoid predators. In summer, its coat turns brown, matching the tundra landscape. In addition, its small ears and short body reduce fat loss. These examples show how polar animals adapt physically and behaviorally to survive in extreme cold. Adaptation allows species to thrive in harsh environments. The professor explains how animals adapt to cold climates. Using examples from the lecture, explain the concept and how the professor illustrates it. Model response. In the lecture, the professor explains how animals adapt to survive in freezing climates. The main idea is that physical and behavioral traits help species live in extreme cold. The first example is the polar bear. It has a thick layer of fat that insulates its body and white fur that provides camouflage, helping it hunt seals. The second example is the Arctic fox. Its fur changes color while in winter and brown in summer. So, it blends into its environment year-round. It also has small ears and a compact body to reduce heat loss. These examples show that adaptations allow animals to thrive in the Arctic. Overall, the lecture emphasizes that survival in extreme conditions depends on specialized traits. Practice test 19, the printing press and knowledge spread. Today, let's examine the printing press, an invention that transformed the spread of knowledge. Before the press, books were copied by hand, which was slow and expensive. The invention of the printing press in the 15th century allowed books to be mass-produced making knowledge more widely available. Consider two examples. The first example is education in Europe. Before the printing press, only the wealthy could afford books. With printed text, schools had greater access to learning materials. This allowed more people, including the middle class, to become literate. Over time, literacy rates rose dramatically. The second example is the Protestant Reformation. Martin Luther's writings were printed and distributed across Europe. Without the press, his ideas might have stayed local. Instead, the press spread them quickly, leading to major religious and political changes. These examples show that the printing press accelerated learning and social change by spreading knowledge more efficiently. The professor explains the impact of the printing press. Using examples from the lecture, explain the concept and how the professor illustrates it. In the lecture, the professor explains the significance of the printing press, which allowed books to be mass-produced. The main idea is that the printing press spread knowledge and changed society. The professor first describes education in Europe. Before the press, books were rare and expensive, but mass production allowed schools and ordinary people to access them. This raised literacy rates. The second example is the Protestant Reformation. Martin Luther's ideas spread quickly because his writings were printed and widely distributed. This caused major religious and political changes. These examples show that the printing press had a huge influence on learning and society. Overall, the lecture emphasizes that the press transformed how people access information. Practice test 20, food chains and energy flow. Today I want to explain food chains and how energy flows through ecosystems. A food chain shows who eats whom, starting with producers and ending with top predators. Energy is transferred from one level to the next, but some energy is always lost. Let me illustrate with two examples. First, consider a grassland ecosystem. Grass, as the producer, converts sunlight into food through photosynthesis. Zebras eat the grass, transferring energy to the herbivore level. Lions then prey on zebras, transferring energy to the predator level. However, with each step, some energy is lost as heat. Second, look at a marine ecosystem. Tiny phytoplankton act as producers, making food from sunlight. Small fish eat the plankton, bigger fish eat the small fish, and sharks eat the bigger fish. Again, energy moves up the chain, but less reaches each level. These examples show how energy moves in predictable patterns, sustaining life at different levels. The professor describes food chains. Using examples from the lecture, explain the concept and how the professor illustrates it. In the lecture, the professor explains food chains, which show how energy passes through ecosystems. The main idea is that energy starts with producers and moves up to predators, but some is lost at each level. The professor first gives the example of grassland. Grass makes food from sunlight, zebras eat the grass, and lions eat the zebras. The second example is a marine ecosystem. Phytoplankton produces food, small fish eat them, bigger fish eat the small fish, and sharks eat the bigger fish. Both examples show that energy moves from producers to consumers in steps, but less energy is available at higher levels. Overall, the lecture emphasizes that food chains explain how life depends on energy transfer. Practice test 21, ecosystem succession. Today I want to explain ecosystem succession, which is the natural process by which ecosystems change and develop over time. Succession can be primary or secondary. Primary succession occurs in places where no life existed before, such as bare rock after a volcanic eruption. Over time, small organisms like lichens break down the rock, forming soil. Gradually, grasses, shrubs, and eventually trees grow, creating a complex ecosystem. Secondary succession occurs in areas where life once existed but was disturbed. For instance, after a forest fire, the land is not completely barren because soil and seeds remain. New plants grow quickly, followed by animals, and the ecosystem slowly returns to its original state. Two examples illustrate this. First, volcanic islands like Krakatoa showed primary succession when plants and animals colonized bare land after an eruption. Second, Yellowstone National Park showed secondary succession after wildfires in 1988 when plants and animals quickly returned. Succession shows how ecosystems naturally rebuild and evolve. The professor explains ecosystem succession. Using the examples from the lecture, explain the concept and how the professor illustrates it. Model response. In the lecture, the professor explains ecosystem succession, which is the process of ecosystems developing over time. The main idea is that succession can be primary or secondary. Primary succession starts where no life existed before, such as on a volcanic rock. For example, the professor mentions Krakatoa, where lichens and plants gradually colonize bare land after an eruption. Secondary succession happens where life was disturbed but not erased. After Yellowstone's wildfires, soil and seeds remain so plants and animals return quickly. These examples show how ecosystems naturally recover and evolve. Practice test 22, the theory of comparative advantage. This afternoon, I want to discuss the economic theory of comparative advantage. This idea, developed by David Ricardo in the 19th century, explains how countries benefit from trade even if one country is more efficient in producing everything. Comparative advantage means a country should specialize in producing goods for which it has the lowest opportunity cost in trade for others. For example, consider England and Portugal. England could produce both cloth and wine, but it was relatively more efficient at making cloth. Portugal was better at making wine. Even though both could produce both goods, England focused on cloth while Portugal focused on wine, and by trading, both nations benefited. A modern example is electronics and agriculture. The U.S. has advanced technology and produces electronics efficiently. Brazil, with fertile land, produces agricultural products cheaply. If the U.S. specializes in electronics and Brazil in farming, trade makes both nations wealthier. Comparative advantage shows why international trade increases overall prosperity. The professor explains comparative advantage. Using the examples from the lecture, explain the concept and how the professor illustrates it. In the lecture, the professor explains comparative advantage, which means countries benefit from trade by specializing in what they produce most efficiently. The professor first gives the example of England and Portugal. England focused on cloth while Portugal specialized in wine, and by trading, both benefited. A modern example is the U.S. and Brazil. The U.S. produces electronics efficiently, while Brazil is strong in farming. Specialization and trade allow both to gain more than if they'd worked alone. These examples show that comparative advantage explains why trade is beneficial. Practice test 23, the role of enzymes. Today I want to talk about enzymes, which are proteins that speed up chemical reactions in living organisms. Without enzymes, many reactions necessary for life would occur too slowly to sustain us. Enzymes work by lowering the activation energy of a reaction. This means they help molecules react faster without being used up themselves. For example, consider digestive enzymes. Amylase, found in saliva, helps break down starch into sugars. Without it, digestion would take much longer. Another enzyme, lipase, breaks down fats into fatty acids and glycerol, which the body can use for energy. A second example is DNA replication. Enzymes like DNA polymerase copy genetic material when cells divide. Without them, cells could not produce accurately and life would not continue. These cases show that enzymes are essential biological catalysts, ensuring that life processes occur quickly and efficiently. The professor explains enzymes. Using examples from the lecture, explain the concept and how the professor illustrates it. In the lecture, the professor explains enzymes, which are proteins that speed up chemical reactions. The main idea is that enzymes make life processes possible by working quickly. The professor first describes digestion. The enzyme amylase breaks down starch into sugar, and lipase breaks down fats into usable parts. Without these, digestion would be slow. The second example is DNA replication. The enzyme DNA polymerase copies genetic material during cell division, which ensures life continues. These examples show that enzymes are vital catalysts in biology. Practice test 24, cultural assimilation. Today, let's look at the concept of cultural assimilation, which occurs when individuals or groups adopt the culture of another society, often losing some of their original identity. Assimilation can happen voluntarily or through pressure. It can involve language, customs, food, or religion. For example, consider immigrants in the United States. Many families adopt English as their main language. Over generations, children may lose their parents' native language. They may also celebrate American holidays like Thanksgiving while practicing fewer other traditional customs. Another example is indigenous communities under colonial rule. Colonizers often pressured native people to adopt their language and religion. In some cases, local traditions were discouraged or even banned, leading to cultural loss. These examples show that assimilation can help people fit into new societies, but also reduce cultural diversity. The professor explains cultural assimilation. Using the examples from the lecture, explain the concept and how the professor illustrates it. Model response. In the lecture, the professor explains cultural assimilation, which is when one group adopts the culture of another society. The main idea is that assimilation can help people fit in, but may reduce traditions. The professor first describes immigrants in the U.S. Many adopt English and American holidays while losing their original customs over generations. The second example is indigenous communities under colonial rule. Colonizers often force them to use new languages and religions, leading to cultural loss. These examples show that assimilation changes identity, sometimes positively and sometimes negatively. Practice test 25, the functions of myths in society. This morning, I want to talk about the functions of myths in human societies. Myths are traditional stories that explain natural events, cultural values, or the origins of people. Even if myths are not scientifically accurate, they serve important purposes. One example is Greek mythology. Ancient Greeks told stories about gods like Zeus or Poseidon to explain natural phenomena. For instance, they believed storms were caused by Poseidon's anger. These myths gave people a way to understand the world before modern science. Another example is Native American myths. Many tribes have creation stories explaining how the earth, animals, and humans came to exist. These stories also taught moral lessons such as the importance of respecting nature. These examples show that myths help societies explain mysteries, teach values, and strengthen cultural identity, even if they're not factually true. The professor discusses myths. Using the examples from the lecture, explain their role and how the professor illustrates it. In the lecture, the professor explains myths, which are traditional stories used to explain the world and teach values. The main idea is that myths play cultural roles even if they are not scientifically true. The professor first mentions Greek mythology, where gods like Poseidon were believed to control storms. This helped people explain natural events. The second example is Native American myths, which often describe creation and teach respect for nature. These examples show that myths explain the unknown and pass on values. Overall, myths strengthen cultural identity. Don't forget, like this video, subscribe to the channel for more TOEFL practice, and improve even faster with my TOEFL speaking and writing feedback service at bettertoeflscores.com. Remember, success is the sum of small efforts repeated day in and day out. And thank you for watching this video.